Hello, everyone. It's Mr. Segan. I'm sad that we didn't really get to get through this problem, and I understand there's a lot of confusion with it. It is a hard problem, so don't feel too stressed out. However, I do want to make sure that you guys understand this, especially for your quiz. This is an important type of question, most probably one of the harder types of questions in terms of these quantifying heat types of questions. So I want to make sure you guys understand this to the fully, and so that's why I am recording this on a nice, beautiful, sunny day. So, during an investigation, we had 200 grams of silver and it's being heated to 90 degrees Celsius. So, it's heated to 90 degrees Celsius before there's any interaction. So, I'm just going to make sure that we understand that this is T initial of our silver. The hot silver is then placed into 300 grams of ethyl alcohol that has an initial temperature of 5 degrees Celsius. And what we need to do is we need to determine the final temperature of the silver alcohol mixture. Now, something that's very important to understand about these questions is that the final temperature of this investigation is going to be the same for both the silver and for the alcohol. Okay? So, there's a lot of variables that are going to be in here. So just like I tried to do at the end there of our lesson, I'm going to make a table for both of them. This is going to be our ethyl alcohol, and this is going to be our silver. Okay? We'll draw a nice line just like that. Okay? So, we know since this is a heat question, we're most probably going to have to be using these formulas, right? And also we have to understand that that's an A. The amount of heat, the quantity of heat that is absorbed by the ethyl alcohol is going to equal the amount of heat, the negative form of the amount of heat released by the silver, right? So QEA is going to equal to negative QS. So in this case, let's write some variables out. Our silver, we know its mass. It is 200 grams. We need to convert this to kilograms because our formula has mass in kilograms. Okay? So that's the first trick right there. Make sure you don't fall for that. 200 grams gets turned into zero point 0.2 kilograms. Okay? Our C, our specific heat capacity, that can be found in this table right over here. And that is 2.4 times 10 to the 2. That's not an E, that's a C. And that is in joules per kilogram degrees Celsius. And our delta T, right? Our delta T is really, if I want to kind of get into a full, more raw equation, it would be TF minus TI. And the reason why you might want to do that is because you're trying to find what TF is, right? So, I'm going to split the delta T into two variables here. We don't know what that is. And we also know that the initial temperature of silver is going to be equal to, 90 degrees Celsius. Our ethyl alcohol, it had a mass of, right here, 0.3 kilograms, or 300 grams. Its specific heat capacity of ethyl alcohol can be found right here. It's 2.46 times 10 to the 3. I'm not going to write the unit just because it's kind of big and I don't have space for that. Our TF, we don't know. That's what we're trying to find. And our TI of the ethyl alcohol, it can be found right here. And it is 5.0 degrees Celsius. And just like I said, the final temperature of the silver is going to equal to the final temperature of the ethyl alcohol. Okay? So, now that we have all of this, let's plug in some values for these equations, right? So, taking in that our QEA is going to be equal to the negative of QS, right? I'm going to just draw a little arrow here. That means that if we sub in what the other variables are in our formulas, you're going to get the mass of ethyl alcohol multiplied by the heat capacity of that, multiplied by delta T of EA, right, is going to equal the mass of the silver times the C of silver times delta T of silver. If we want to break that down even further, we could say that MEA times CEA multiplied by TF minus, and actually I'm going to make TF a different color. Let's pick any color. I'm going to choose, we're just going to choose black, it's easy. TF, right, minus our TIEA. That is going to equal our mass of the silver times our specific heat capacity of silver multiplied by our final temperature, which is shared between both substances, right, minus our Ti of silver, our initial temperature. Wow, what a lot of variables. That thing looks absolutely disgusting. What I suggest you guys do is, for this type of question in particular, I really feel like it's helpful if you just plug in the numbers right at this point, okay? Typically, it doesn't matter if you choose to plug the variables in before you isolate or not. Like, you could still do it that way, but I'm going to recommend, it's a lot easier if you just combine a lot of these numbers together. Makes things a little bit more organized and more clean, okay? So, here are the numbers. Ooh, there we go. There are the numbers right there. I'm going to write these out. I also have them written right here. So our mass of our ethyl alcohol was equal to 0.3 kilograms, right? Our specific heat capacity for ethyl alcohol was 2.46 times 10 to the 3. Joules per kilogram degree Celsius. And then we have our TF minus what our initial temperature was of ethyl alcohol, which I can see in the top corner, was 5 degrees Celsius. Now, all of that is going to equal to our mass of silver, which was 0.2 kilograms, multiplied by our specific heat capacity of silver, which was 2.4 times 10 to the 2 kilograms degrees Celsius. And then all of that is going to be multiplied by our final temperature minus our initial temperature of the silver, which was 90 degrees Celsius. Right? Okay. So, why don't we go ahead and plug all of those numbers in. The first thing I'm going to do is I'm going to multiply that 0.3 by 2.46 times 10 to the 3. And the number that I got was 738. And the kilograms are going to cancel out. So we're going to get 738 joules per degree Celsius, if we really care about units, right? Those kilograms are going to cancel out. And that, all of that is multiplied by TF minus 5 degrees Celsius, right? That's going to be equal to what is, this also has a negative sign. I forgot to add that. Guys, there is a negative sign in front of all of these. If we follow that that equation we had before, right? There's a negative sign there. So we have negative 0.2 multiplied by 2.4 times 10 to the power of 2. So that number, what I'm getting is negative 48 joules per degree Celsius. All of that is multiplied by TF minus 90 degrees Celsius. Right? A lot smaller, right? A lot less variables, a lot easier to see. So now that I have that, what I'm going to do is I'm going to multiply the 738 by TF and the 5 degrees Celsius, and you're going to see what we get. So we get 700. We're going to expand. That's the wrong thing. We're going to be expanding. Sorry, I'm going to restart that. We are going to be expanding the 738 to both the variables in here, and then also the other variables like this. Expansion, right? It's something you should have learned hopefully in grade 8 algebra. So here we are. We end up with 738 TF, right? And that's, I'm just going to drop the units for now because it might make things a little complicated. And that is minus, what is 738 multiplied by 5? That should get me 3,000. Oh, does that sound right? I'm pretty sure that's right. It should be minus 3,690 joules. Right? I just said I was going to drop units. 3,690. Okay. That is equal to what is negative 48 TF. Sorry. Negative 48 TF minus what is negative 48 multiplied by negative 90. That's going to turn out to be a positive. So we end up getting something that looks like 4,320. I believe that's what happens, right? If I do what is this? Negative 48 multiplied by 90, 4,320. Good. So that checks out. We still need to isolate for t. So we need to bring one of the t's over to the other side. I'm going to move this one just because it's negative and it's going to turn to a positive. And I like addition more than subtraction. So 738 plus 48, that's going to get you to 786 TF. And that's going to equal to, if we move this over to this side, we end up getting 4,320 plus 3,690. That's going to be equal to 8,110 or 8,010, right? Now, in order to get TF by itself, we just divide 8,010 by 786. And your final temperature is going to be equal to, hopefully you get this, 10 degrees Celsius. Or I believe it's something like 10.2. But with significant figures, it's going to be 10 degrees Celsius. So wow. Holy, what a question. A lot of information there. The main takeaway that you got to do with this is that the formula here, very, very important. Delta T is equal to the final temperature change. Make sure there's a slider. It's the final temperature subtracted by the initial, right? And then you just have to take in all of the variables, write them out like this, and then you can plug the numbers in and kind of get your way to getting TF. The main trick, and you'll see this with all of these final temperature questions, or initial too, but mostly it's going to be final temperature, is that your TF or your TI is blocked. It's locked in these brackets. So in order to do that, you need to expand. You need to expand those numbers in front of delta T in order to get whatever temperature you're looking for freed. Okay? If you have any questions, let me know. I'll most probably go over something super, super quickly on Friday about a question just like this. Okay? Thank you so much for listening and enjoy your day.